Let's take a look at nim, the programming language that's statically typed and compiled, and the language itself is super clean. It's the way I like to see languages when we're dealing with, building applications for any kind of server or user interface. I want to see a nice clean syntax. All of those symbols that can fly around can make the language confusing, as well as a lot of abstractions, which are rarely needed in these days, where a lot of the code is tending to be, debt and treated as throwaway. We'll be rewriting it anyway, so why not make it as simple as possible so that way that eases our burden going forward. Nim does a really good job at that. Taking a look, we see some very clean and elegant syntax. They took the ideas from Python with indentation that helps define scope and ownership of these various parameters. They did a really good job. Obviously, you don't want to restrict indentation too much, because then you can't make elegant sort of views like this that let you know that you're encapsulating multiple lines worth of information in a list. And it's great to see this octothorpe ## symbol that is the number sign, right, as well, that it says these are comments. I like that because it's just a simple one keystroke. Well, I guess it's a shift 3, right, as a shift on the keyboard. So you're still doing 2 keystrokes, like comparing with C and Rust, where you would have a /, like 2 forward slashes. You still have to click to. Though, guess what? You're only still dealing with one symbol at the end of the day, so the overall result is a cleaner look. And I would say it's actually pretty easy to confuse this with Python, because it looks a lot like Python, this syntax. It's very clean and minimal. There's some nice syntax here, like echo instead of print. Sure, echo, print, I suppose. Either works. I feel like print is a little more. Echo is fewer keystrokes. There we go. Helping reduce the overall footprint there of code. Then we also have this nice little FMT in front of our string starting, and then a string terminator. We can see that this is nice. I like that. We're going to see for every person inside of people, where we've defined a list up here of persons inside of people, we're going to be printing out the name and the age in one line. That is super clean. I really like that. It totally makes sense. Also, the ability to say FMT allows you to put it more than just like an echo printout scenario. You could also assign this to a variable. And then you can create an iterator, which is neat, although I see we're getting a little crazy with the syntax here. It was kind of, the kinds of things that I like to avoid, because what is even going on here? We do see some in some generics type situations but the inside of it is pretty straightforward. We've got a for loop, an if statement, and then a yield, where it's going to yield to the value of X as long as it's an odd number. And so now we've got ourselves an iterator that took in an array, and it's going to print out all the odd numbers. That's actually easy, super easy to read, super clean. Let's take a look at more of NIM's example on their homepage, some example basics from their language. Let's take a look at the if else and the case switch statements. Taking a look, this almost looks exactly like Python. The language itself, the indentation, the colons here. The only thing that's not Pythonic is this var. So to declare a variable, you would just say the conditionals 42. And then you check the conditionals range, and then you echo out, or you print the result based on the condition, which is super clean. I like that. So that's really straightforward and simple. There's also built-in ternaries, which is nice. You've got this if-else statement here. You can do multi-line ternaries. Whoa! Look at that. All right, so this is actually a nice feature in Rust as well, where you can assign a variable to the output of a conditional statement. It's a little weird to look at first. You're like, wait, what's really going on here? Oh, okay, so we're assigning a string variable based on the condition. And then we look at the case switch statement. Actually, really straightforward. Case letter of A, of B, C, of D to H. Oh, wow, they have ranges. That's kind of neat. Oh, it's neat to see that they've got a range there. Otherwise, the default, the letter is another character outside of the range of what we're looking for in our case switch statement. Now we're going to take a look at some basic math operations in NIM's programming language. It looks like we import some functions here, standard math, that's going to add some of these, like we get pi, tau, square root, round, is power of 2, and a whole bunch of other common math functions that you like to use throughout the day, although I don't usually. Oh, cool. Okay. Euclidean division. Looks like we're going to get some whole numbers here. Oh, there's an almost equals. I like that. That's kind of fun. Assert almost equals pi to 3.14. Now, of course, pi has a whole bunch of digits, and we don't know where the end is on that, so you get an approximate. All right, now we're going to take a look at NIM's string operators in their simple examples here on their homepage. And then we import a few items here for string. Our concatenation is an ampersand. Now, in other languages, it's going to be a plus symbol, right, where you're adding the two strings together. That seems a little more natural to me. B, that is kind of common. Other languages use a period, right? That could be another option. Or, oh, neat, look at this. Okay, so the string literal itself has access, kind of like JavaScript, to these kinds of functions that are built into the literal. So you can remove the white space symbols, like space characters and other kind of characters. That is great. We've got a parse int, a parse float, a hex int, a parse boolean, and a parse octal, right? So 0 to 7 is the range there on the octals. A nice little built-in repeat statement. Oh, it checks to see if it starts with and ends with. Some of these are pretty nice common programming patterns that you need to have within the language. It's really nice that they just bring, it's like batteries included, right? It's common string functions there. Of course, you got join, which will take an array and then join it together. Oh, it's got like an index finder. Find the C, and it says which index it's going to be, 0, 1, or 2, and this letter C is going to be at the 2, the third position, right? Because it's 0. It starts with 0. Oh, you can count how many times you see A. I don't often use something like this in a production setting, but it is kind of neat that exists. This is interesting, a normalize function. So you can just grab, probably ASCII characters that are alphanumeric, probably just alphanumeric. There's an unindent function. I was not expecting that. So I see an indent function, right, where you're going to add 4 spaces, right? We're adding 4 spaces. You can also center. That's kind of neat. And then there's an unindent, which removes the indentation. And a nice tokenize. This is great because you can apply a whole bunch of commands in a sentence, or maybe you're actually looking for tokens to convert into a lookup table, right? You might be preparing data for training on AI and machine learning. One of the things I value about NIM is its syntax simplicity. I really like how easy it is to read the code and walk through the details step by step, because it feels natural, like natural human language. Now, this is where I don't see, I am having a little, I understand what's going on here, but I don't like it. So we're looking at comprehensions, I suppose, like list comprehensions, right? So we can assign a variable here, variable 0, to, I'm not exactly sure what's going on with collect new sequence, right? And I can see that I'm expecting me to iterate over this array here, this list, and I'm going to multiply each item by 2. And the variable is going to be a new list that is double, or multiplying each item by 2. And then we can see that variable 0 here, variable 0, is going to be essentially equal to double what we had as in the input. The part that doesn't totally make sense is this collect new sequence. And I see this pattern here, collect init table, collect init hash set. So we have a table and then we have a set, right? A number set. It's just not obvious what this part is here, just, being new to the language myself. I don't know where these come from. New sequence, initialize table, initialize hash set. What are those? Where are those? I'd say like maybe Python syntax is probably a little more concise in this case, being able to just put brackets on either side here and assigning that to a variable. So you have overall less code, and it could be on a single line. You don't need this statement here. At least we can see that this is how NIM wants you to do it. From when you are iterating over items, you can iterate on the list, apply logic to each, and then it returns the end result. So this is a map, right? Sort of like a map. You can also throw a filter in there probably. And in that case, it is cleaner because there's a nicer way to throw it on multiple lines, and it's kind of obvious in that case. So I see what's going on. We're creating a set here, and we want to make sure that the set is matching our expectations when we're adding these together. Although I'm reading this one right here, and I'm variable 2. I guess these brackets are throwing me off, but it says item plus item, which tells me it's like item times 2 almost. But I see -9 here, but it's expecting an output of 2. Wouldn't this be -18?